Now we have another question. We have here, this is the uniform rod and this is the thread. So from here we understand that the thread will hold this point, so that point is going to be the pivot for this situation. Okay, so I can write here, this is the pivot. Okay, a student hangs a 6.0 Newton weight on the road so that it is in equilibrium. What is the distance of the 6.0 Newton weight from an X? In order to solve this, we need to write this equation. Clockwise moment equals anti-clockwise moment. Because it is given in the equation, it is equilibrium. So, when we have this uniform rod, and we know that the weight of the uniform rod is 2.0 Newton, so we need to point out where actually the weight acts. The weight seems to act from the middle of the rod, so it should be here. This is the weight, 2.0 Newton. And then another weight is hang here, but we need to guess where it should be. Okay, so let's say we put it here. So now we have, it is 6 Newton here, and we don't know what is the distance here. We don't know what is the distance, and the distance between X to the center of the rod is 40 centimeter, because the total length is 80 centimeter, so half of it should be 40 centimeter. Okay, let us try to find out what are the clockwise moments. Okay, the first one is, let's say this length is L. Okay, let's say the length here is L. So L multiplied by 6. Okay, remember this is the force, plus, remember we have two moments here. The first moment comes from the weight, and another moment comes from the weight of the rod itself. Okay, 20 centimeter. 20 centimeter is the distance between the pivot or the thread to the middle of the rod. That is 20 centimeter. How do you know 20? It is 40 minus 20 centimeter. So that's why we have 20 centimeter. Okay, this length, 20 centimeter multiplied by 2. 2 is the perpendicular force. And then we need to find out the anti-clockwise moment. Anti-clockwise moment is this one, because it will go this way. This is anti-clockwise. For the clockwise moment, it goes this way and this way. So let's go back to anti-clockwise, this one. So the force is 5 Newton, this is the force, and 20 centimeter is the perpendicular distance. And then when you have this equation, you can solve it. Okay, you can pause the video to take a look at it. And now we have this equation. It has been simplified, and then you find out what is L, and finally we have L is 10 centimeter. So this distance is 10 centimeter, but the question here is, what is the distance of 6 Newton weight from an X? Okay, from an X, it means from here. So you need to find what is the distance, this one and this one. So you have 20 plus L. Okay, L is here. Here's L. So L plus 20, so you have 30 centimeters. So this is the answer. You can watch again if you think you need to watch it for better understanding.